Welcome to Python for Scientific Computing 1. Reading data that are in files into Python for analysis is an important component of many numerical and scientific computing tasks, such as regression. There are libraries specifically designed to read data into Python. The Pandas library, which stands for panel data, is one such library that's widely used. In today's video, let's take a look at Pandas and NumPy and see how they can be used to read data into Python. Most data that we use in numerical computing is usually stored in spreadsheets or databases. A spreadsheet essentially is a table of data that is arranged in rows and columns. And a relational database typically has multiple such tables that can be joined together using relationships. Therefore, we can query the data and create views or tables of data that we can then use for scientific computing. There are many formats in which we can store data. Format that we'll be using in this class is going to be the comma separated value format. CSV format, or the comma separated value format, stores data in ASCII, and it's not a binary format. And it also has the advantage that CSV data or CSV files can be opened by both commercial packages such as Excel, as well as open source tools. Of course, we can do this in many ways. We can make use of the CSV library, we can make use of the NumPy library, and we can make use of the Pandas library. Each of these libraries have their own strengths and limitations, and they are well suited for specific types of data sets. For numerical computing, we will mostly focus on the NumPy library and the Pandas library. The NumPy library is extremely useful to read matrix data. If you have a matrix in a comma separated value file format, then you can use np.loadtxt and give the file name and the delimiter. If it's a comma, then comma would be the delimiter, but you can also use other delimiters such as the pipe delimiter to store or read data that is stored on your hard drive into the computer. The loadtxt in NumPy is useful when there are no missing values. And if there are missing values, then you use the np.gen from text with a file name and a delimiter to read in your data. NumPy is extremely useful to read homogeneous data or data of one data type. However, if you have data arranged in rows and columns with multiple different data types, we call that the heterogeneous data, and the Pandas library is better suited for that. So to read a matrix into Python using NumPy, what we first need to do is we need to import NumPy as NP. Then I'm going to import OS. OS is a library called the operating system library, and this library is used to interact with the operating system on your computer. Here, I'm going to set a path. The path is where my file resides. This is the folder in which my file resides. And in Python, the paths are given using forward slashes. So if you're on Linux or Mac, this is typically how the path is written in these operating systems. However, if you're on a Windows framework, then we use the backslash, which Python doesn't recognize. So either you have to put double backslash or simply put a forward slash. os.chdr path will change the path. And then if I do os.getCwd, getCwd stands for get current working directory. It tells me that my current working directory is home VRMary Python 1 course. So when we set a path and make that our working directory, what we are doing or essentially telling Python is that when I ask you to read a file or write a file, essentially look for it in this address or in this folder. I should have a file named matrix.csv in this path or in that folder. And if I do, that file would be something like this. Okay, I've created a matrix file, essentially put a sequence of numbers in a spreadsheet and then saved it as matrix.csv in that folder, the folder being my home directory or the path. I use np.loadtxt with the file name and the delimiter, and I can read that into an object A. A.shape tells me that there are 5 rows and 5 columns. Remember, shape is an attribute, so I don't need to put parentheses. Similarly, once I have A, I can use A and call a method np.linalg.inv and use and calculate the inverse. If I have heterogeneous data, then I use Pandas library to read that data. Pandas is a very versatile library and it can read data and write data to a variety of different formats. The generic statement is read underscore star. That star can be a CSV if you're using CSV data, XLS if you're using data that's in Excel format, HTML, JSON. So there are several types of data that you can read using the same generic command, read underscore, whatever the format there is. Okay. And that creates a data frame that has got rows and columns. Again, while pandas can read many different data types, it is best to use the CSV format because CSV format is read by both commercial and open source programs. Pandas offers us two data structures. The first one is the data frame. The data frame essentially is like a spreadsheet. It's got rows and columns. The attribute names are the columns, whereas rows contain data sets. I could have several attributes in several columns, and then I could have several rows of data, and each row is identified by a unique index, which starts at 0 and continues downward sequentially. If I take one specific column of the data, then I have row index, the values of a particular column, and that is called a data series. So a data frame can be viewed as a set of data series, each containing one unique attribute. To explore pandas, we shall make use of a data set that is available to us on the web, namely the concrete strength data. This data has 9 attributes, a variety of different components that went into making a concrete sample, and finally the strength that was measured. And then there are 1030 rows, each row corresponding to one sample that was prepared in the lab. If you want to download this data, just go to your favorite web browser and type in Kaggle concrete strength data, and you will get to that data which you can download. I have downloaded this data and put it into my working directory and named it concrete strength data.csv. To read that data into pandas, what I do is I first import pandas SPD. I've also imported NumPy and I've also imported OS. I'm using OS to set my path and change my current working directory to that path. Concrete strength is the name of the file, so I'm defining fname as concrete strength data.csv. This file has to be in this working directory for this code to work. Then I define an object A. A is equal to pd.read underscore CSV. File name. PD implies that it is coming from pandas. And then read underscore CSV is the method or the function that's associated with pandas. And then it takes an argument of fname, which is the file name here, which is concrete strength data.csv. And if I do a.head, it gives me the first few values. Then I do a.describe, which gives me the summary statistics, the count, the mean, the standard deviation, and such of all the components that are in there. So a.describe is a way to get summary statistics and is particularly useful if you have numeric data to get a quick idea of the range of variability as well as the typical values and others and different quantiles that you're going to see with this data set. So a pd.read underscore CSV with the file name defines the object, reads the data that is in that file, and puts it into an object A. This is a pandas object. And if I do a.head, then it gives me the first few values. X is a number that you can put there to see how many values you want to take a look. And a.describe in parentheses is a method associated with that object A, which gives me the summary statistic. Pandas also has several features or attributes. For example, the pandas object A dot columns gives me the list of columns. So these are attributes, so I don't need parentheses. So it tells me that there are several columns in my object. And if I do a.dtypes, it'll tell me what is the data type that's associated with each of these attributes or columns that are in that object A. Notice here that the cement component has a space in it. This is the space that can cause problems later on. So what I'm going to do is I'm going to use a.rename. So essentially I'm saying that this old name is being replaced by this new name using this a.rename. Rename is the method associated with that pandas object A. And I'm also going to do this in place, which means I'm going to take the original A and change it in place rather than make a copy and store it. So once I have my data set and I've looked at that data set, then I can start working with that data set. I want to extract values that are in individual columns or a few columns, and I can do that very easily using pandas. So for example, if I want the strength column out, I simply can create a new object called strength and say a dot strength, and a dot strength will give me a series. Notice I had said that data frame comprises of many columns and each column is a series. So when I extract a single column, it is extracted as a series. And then another way to extract a single column is used to use the square brackets. And so if I put A, which is my original object, square bracket, and put strength in quotes, then that becomes a single column for me to work with. If you want to get more than one column, what you need to do is you need to pass a list, and the list is basically strength and water component. These are the two components that I want, and I'm going to put them in a list. The lists are defined using square brackets, and then I say a square bracket, and it'll give me these two columns. Pandas also offers a way to extract specific rows and specific columns by names, and that is using the lock command. If I do a.lock, this is lock stands for location. I want a of strength greater than 35. So I want all rows where the strength is greater than 35. And I want two columns. One is the column named strength, and the other one is called the cement component. So if I do a.lock, I put a strength greater than 35, and here are the two columns that I want. So this is the criteria by which I filter the rows, and these are the columns that I want from that filtered data set. So when I put that, it gives me strength, and then it gives me the values. You can see that the minimum value is 35.08. There is also an index-based subsetting of data, and that is done using iloc. In pandas, just like anything else in Python, indexing begins with 0, and the first index is included, but the last index is excluded. For example, I can do a subsetting of the data using iloc. So I define an object called subiloc, and I say that's equal to a.iloc. So this is index-based location. I want to go from 0 to 10. I want the first 10 rows of my data set, and then I want the first 3 columns. Remember, index starts at 0, so if I want to get to 10, it doesn't quite get to 10. It stops at 9. It's going from 0 to 9, so it pulls out 10 elements. And then from 0 to 3, it pulls me 3 columns, the first 3 columns, but again, the indexing starts at 0. So cement component is the first one, blast furnace slag is the second one, and fly ash component is the third one. So these are the 3 columns that it pulls out, starting with the index 0. So index 0, index 1, index 2 are the column indices or the axis indices for this iloc. Pandas can also be used to visualize data. You can make plots to get a quick look at the data in a visual mode, just like you would get describe, which is a way to look at data numerically using summary statistics. There are other libraries such as matplotlib, bokeh, and others that offer much greater visualization capabilities than pandas, but pandas visualization is largely useful for exploratory analysis. I can do, if I have an object A, pandas object A, then I can do a.plot. I can tell the kind of plot that I want, and then I can give the X component, the Y component, and the color. It gives me a plot that shows how my strength here is varying with my cement component. Similarly, I can make a box plot. To do that, I create a new object A, which has these two, a strength and water component. And then what I do is I create a box plot of these two elements. You can also make a kernel density plot, which is like a PDF, an empirical PDF or a probability density function. To do that, I extracted a.strength, and then I did strength.plot.kde. I can give the bandwidth, I can change the bandwidth to make this plot smoother or coarser. By changing this bandwidth, I can get a distribution associated with that variable. So in summary, homogeneous data, particularly matrix data, can be read using NumPy. If it is in a CSV file, it's very useful to import matrices. However, if you want to import heterogeneous data, the best way to do that is to use Pandas. Pandas offers two new data structures, a data frame and a data series. A data frame comprises of multiple columns and multiple rows. A data series only comprises of one column. Pandas has some useful tools to work with tabular data. You can visualize the data. You can summarize the data using summary statistics. You can slice and dice the data using lock and iLock, and you can filter rows as well with iLock. And then Pandas also has some basic visualization capabilities, not necessarily to make scientific plots, but to help with exploratory data analysis. And it can make you scatter plots, box plots, and density plots. Overall, Pandas is a very versatile tool for data analysis. It is something you need to know in today's scientific computing environment because we do a lot of data-driven modeling, as well as use data for calibrating our models and such. So Pandas is a great way to bring data and visualize data. I hope you found this video useful. Again, I've only scratched the surface with Pandas. Feel free to explore Pandas by visiting their website, as well as there is a wealth of information on Pandas on the web. So hopefully this will get you started on exploring the various aspects of Pandas that will be useful for you in your scientific computing endeavors. With that, I will conclude this lecture and I will see you in the next one. Till then, take care, stay safe, and goodbye.